All right, it is Sunday, November 2nd, 2025, and it's day two of the 30-day map challenge. So I created this map, and day two is lines. So map linear features, roads, rivers, migration paths, flow lines, explore line thickness, color, and direction to convey information. So this is a map of the 10 most congested urban areas in the United States, as compiled in a study by the company INRIX. And what we're doing is we're visualizing average annual daily traffic and vehicle miles traveled, and that data is from 2020 in an Esri data set that we're going to look at. So somewhat related to the point map that we did yesterday, in that many of the urban areas identified by the point density cluster analysis also appear here, perhaps unsurprisingly, in our top 10 list of the most congested urban areas. So as you can see here in the legend, I'll just zoom in a little closer here. You can see that the line thickness is based on the annual average daily traffic, and the color is based on the annual vehicle miles traveled. Now that's a little tricky to understand, but what it's saying is that traffic goes slower where it's red, and that means more vehicle miles are traveled on those segments of highway. So you can see here, New York City, the thruway is kind of a good example. New York City, Los Angeles, these were tough to represent because they're just so dense. But what I wanted to mention is that the style of this is kind of inspired by some of the maps that my Rutgers cartography professor, Michael Siegel, created in his book, Mapping New Jersey, which I fortunately have here. And it's full of really, really great information and maps and examples. Took 2 courses with Professor Siegel at Rutgers, and finally getting back to doing some of this cartography work, although I've got a long way to go. And that's why the how-to video focuses really on the GIS component in ArcGIS Pro. That's my strength, and I'm building the cartography skill set through this 30-day map challenge. So definitely not a cartographer or presenting myself as any kind of expert in that regard. But I do know a thing or two about GIS, and that's what I hope the benefit of these videos will largely be. So let's jump into the data sources and the creation of the initial map here in ArcGIS Pro. So if you saw the video from yesterday, here's day 1 points, my map, and the layout that I used to export. There's my USA major cities from yesterday. These might come back in future maps in the 30-day challenge. And then I have 2 layers here, interstates and interstates label. So before I add those to a new map, let's just take a look at the data sources that I'm working with. So we'll start with the transportation data set. And this utilizes National Geospatial Data Asset data from the Census Bureau, and it includes really all the roads in the United States. The next up is the Highway Performance Monitoring System, and this has incredibly valuable data on number of lanes, traffic counts, average traffic volume. This is excellent data. I didn't know that this existed at first, and went to the actual federal transportation site, and it was an intimidating process to even try to get started with these traffic counts. But fortunately, the Esri and the federal user community has curated and maintained this layer. The data is current as of 2020. So this is what we'll be using, and this is kind of the primary data being symbolized in the map, is coming from this Highway Performance Monitoring System layer. So let's pull this layer into a new map. I'm going to copy the URL. I'm going to create a new map in ArcGIS Pro. And we're going to name this, I always name the maps immediately. Day 2, lines. and we're going to add data from path. And that will add the hosted feature service to the map. And it's huge. So I'm racing to zoom in so it doesn't try to render the whole thing all at once. So let's zoom in here. I just instinctively zoom on my own location. There we go. Okay. What I want to show is a little sample of this data. If we take a look at the attribute table, I just selected 109 features from that little box. So if you're familiar with hosted GIS data, you realize this is a huge data set if the road segments are broken down that small. So let's take a look at the data in the attribute table. It's taking a long time to load because it's such a huge layer. Which is why I added it to the file geodatabase in advance, because it's slow and time consuming to work with such a massive hosted data set, because we got to connect to it and then interact with those millions of records. So let me close the attribute table, clear my selection, and just review the process that I used to bring this hosted data into my local file geodatabase in the ArcGIS Pro project. So selection's cleared. That'll take a moment to refresh, and I'd like to show the history of this particular layer, because it was a project that I did, and it took 26 minutes. So what I did is I filtered out all the interstate highways from this layer, selected them all, and then projected them into my file geodatabase, into the equal area projection that we've been using. And that took 26 minutes. So to save that time, I've just gone ahead and done that ahead of time. So let me remove the hosted layer from the map. And I'm going to add the result of that project tool, which is interstates. And this is the interstates filtered out. So still a massive data set because of how the line segments are broken down so small. So we can see here, we just have the interstates now. And if I open up the attribute table, I'll give that a moment. So 162 features from that selection. And if possible, we'll open up the attribute table. Now, I'm not entirely sure why that's failing, but since I closed the attribute table that was loading from the hosted feature layer earlier, it's probably still trying to do something in that component of the application. So as I always tell students in the GIS lab, closing and reopening the application is a standard part of the workflow. And it's really not that bad. So just save your work, save, close it, reopen it, and we're back in business. So what we're doing is trying to take a look at the attribute table of this highway performance monitoring system layer, because there's a lot of valuable information here that we're going to symbolize in our map in just a moment. So look at all this great data on the interstate highway system that we have access to. The year record is 2020, and we've got identifiers, we've got functional system, we've got, let's see, average annual daily traffic. That's a good one. We've got lanes too. Through lanes, that's a really good one. And let's see, not everything's populated for all segments, but we have what we need: annual vehicle miles traveled. And you can see I've selected this along a particular stretch of highway, and the numbers are all kind of within the same general range. So So these are the interstates that we want to symbolize based on their based on their annual vehicle miles traveled and the total number of traffic. Sorry, I was thinking I didn't show the maps that inspired this map yet. So we'll get to those in a moment. First thing, I'm going to set the base map to a dark gray canvas. Why? Well, because the example that I'm using from Michael Siegel, Mapping New Jersey, used this dark background to map the linear features of these highways. And I kind of liked how they popped out against the dark background. So that's why we're setting the base map to be darker in this case. And then for the lengths, or the widths and the color, I got some inspiration from this other map, Highway Traffic Census from 1922. So he didn't actually make this one, but he included it in the book. And it made its way into my design process. So let's start symbolizing these interstates based on those two attributes. So we'll open up our Symbology tab, and we'll change this to proportional symbols. And we'll change the field that that's based on to the average annual daily traffic. Now look at that. This is smart mapping. I just said show me proportional, and it doesn't look bad. This is immediately telling me some information that the highways in Philadelphia are more congested. They have a lot more daily traffic than, for example, the Pennsylvania Turnpike or the Northeast Extension. But we can take this one step further and bring in the actual time that cars spend waiting on these particular highway segments. Now pay attention carefully, because this is a little hard to find, but we're in Symbology. We chose proportional symbols, and now I'm going to select Vary Symbology by Attribute. I'm going to select Color. I'm going to go down to the field that I want to symbolize by color, which is annual vehicle miles traveled. And I want this to kind of follow a traffic light. Green for fast, yellow for not so fast, and red for slow. So let's go ahead and pick a good color ramp to get started with. And we can just grab the generic black and white one and make it what we need it to be. So let's set this to green, and let's set this to red. And fortunately, green turning into red provides yellow in the middle. Now this is all right, but we're not seeing a ton of variation here in the Philadelphia area. But let's explore the map a little bit and see how that breaks down. So there's some yellow. Let's see, do we have any red up here? Ooh, there's some red. The southbound lane, check that out, of the Turnpike, much worse than the northbound lane. And I've certainly experienced that going up to Vermont and New England. So this isn't bad. We can kind of look at the larger country, and the symbols will do their best to adjust. But what we're seeing is a lot of green. We're not really highlighting the areas of congestion. That's the thematic focus of the map. So to get our thematic focus, and let's take a look at the West Coast. Less green here. No surprise. LA 405. But I don't want it to be so green. I want to highlight the red areas. So what I'm actually going to do is add a transparency to the color in the ramp of 100. You might say, why? Why'd you do that? Well, because it got rid of all the green. Now look at it. It highlights, while still showing in green, the areas that have fast traffic flow. But you get a lot more of that congestion color, which is what I'm going for. So that's the essence of the initial symbology. And I think it's pretty remarkable that not only do we have this access to this data, but that the application has this smart mapping capability where it's largely intuitive. You just add it to the map and it begins to display in a meaningful way. So great, that is the first component. Now, what I want to do is label all of these features so we know what highways are what. And remember how many features these were broken into? So labeling could be kind of a nightmare trying to consider all of these features. Simply for performance, panning around the map, I want larger segments for my highways. And that's where that second layer of transportation comes in. So this is what I imported using that same process, copy the URL, add it to the map via the path, and then project it into the map project. I've already done that, and it's what I've named interstates label here in the file geodatabase. So I'll go ahead and add that to the map. I'll give it a nice generic white symbol. And this also accounts for that little bit of discrepancy we might encounter if that 100% transparency is reached anywhere. There would be a gap in the network. This resolves that because the thin white line would ensure connectivity of the entire system, meaning the map is more accurate. So there's our lines. That's the easy part. And now the really fun part of creating the labeling to show the highway shields based on this data in the interstates label class. Let me drag that underneath my primary symbology class and take a look at the attribute table. Base geographic name, that looks like what we want to use as our label. So let's go ahead and have our layer selected, go to labeling, select label. The default is nothing like we actually want, so I'm going to start changing these properties. And the first thing is I have these helpful highway shield icons right here in the symbology template. So I'll go ahead and select that. And then for placement, where are we going to place these? Well, I want them all to appear straight and to be horizontally offset. So I'll select that option. And I don't want to see any duplicates. So let's remove all duplicate labels. So now we'll only see them where it matters. So we can see this is 405. This is I-5 right through Seattle and on up towards Vancouver, I-90 going west, and I-5 continuing south. And we see, what's this I-705? Well, there's this little stretch into Tacoma. And that's captured because of our interstate label class. So not bad. We're actually moving along here. We've got the map ready to go. I'm going to turn off our reference labels, and the next step is to create some bookmarks that we're going to load into our template. So let me pull up the list of areas that we want to focus on. And this comes from a report from INRIX, which I had not heard of before today. But I had challenged ChatGPT to give me a list of the top 10 urban areas by their congestion in the United States. And it just pulled this list. It didn't really do anything that creative. But this is where it's coming from. It's coming from INRIX. So what I'm going to do is create bookmarks for these top 10 locations. and then we're going to build a template out of it. This really is not that difficult. Bookmarks. Map. Bookmarks. New bookmark. We'll call this Seattle. And you know, let's just grab one of Seattle, Portland as well. These just a quick note, doing a research paper on mega regional geography, and the traffic flow between urban centers is incredibly important in that research, because as you saw yesterday, our point density cluster identified the Cascadia megaregion as a single contiguous urban area. But if we look at the traffic flow in the interstate between the Willamette Valley, which you see to the south, and the SeaTac metro area around the Puget Sound, which you see to the north, there's not a lot of traffic going that way. Not as much as in other contiguous megaregions. So it tells us something about the flow of people, vehicles, goods, commodities between these different areas. So the Bay Area actually didn't make the list. I think people just gave up on driving in San Francisco, so they don't go anywhere. But here's Los Angeles down to San Diego, and you can see here on I-5 a much thicker red line than we saw in between Seattle and Portland. So this I would argue may be a contiguous megaregion just based on this data that we're looking at. So let's grab a screenshot of this, or not a screenshot, a bookmark. Another bookmark. This is the way to do it with bookmarks. Don't make multiple maps for different views of the same data. Use bookmarks. The bookmarks can be accessed and put into map frames in the template like we're going to see in just a minute. Let's call this Southern California. And I'm sorry about the clicks. I'm not going to edit them out, so my apologies. I know it's annoying to listen to, but my video editing capabilities are not there quite yet, but soon. Soon I will have automated click removal, and everyone will be happier for it. So moving on, going to try to do these in geographic order. Houston. Let's get right there where it looks kind of like a starfish. All right, let's go on up to Chicago. The Chicago metro area. Lots of traffic here. Maybe an example of that zero daily traffic value that we had in our transparency. Let's bookmark it and move on. Chicago. All right, next up is Atlanta. Back on down to Atlanta. And if you've ever flown into Atlanta and had to go north, you know how great that traffic is. All right, and then on down to Miami. And Miami's just an uninteresting blob, so we're going to include all of southern Florida because that's much more interesting. And we'll call this Southern Florida. All right, let's move on up the coast. It doesn't matter what order we do this in. All of them will appear in our bookmarks. Now let's see DC, Baltimore. Grab a bookmark of this one. This is supposed to be a silent keyboard. I installed little circular rubber things on every single key of this keyboard with the tiny instruments, and it still is incredibly loud. So that's the last time I'll mention that. Here's a bookmark of Philadelphia. And then the big one, New York City, number 1 on our list. And see, there's that southbound throughway traffic. So there's an interesting thing to consider here. Just put NYC. In that you can't really tell that it's just the southbound lane that has that high congestion value. So that's a cartographic failure on my part. But with just a day to create the map, we've got to make some sacrifices. All right, let's take a look at Boston. Make that bookmark. Now there should be 10 of these. I've probably missed one. Let me just count them quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because I did Seattle and Seattle, Portland. Okay, perfect. So now we've got 10 bookmarks. We can create our template. Now, I made the template pretty big for the layout. Made the layout pretty big. ANSI 17 by 22 inches, which kind of lines up well with the 6,000 by 6,000 pixel limit for the LinkedIn post image. So let's pick ANSI C. And again, always immediately name these things, or else confusion is unavoidable. But now we've got our template. I'm going to close our label class window, and I'm just going to start pulling in map frames based on those bookmarks. Pretty great, actually. So I'm going to pull up my example on the right hand side, and we'll try to recreate this as quickly as possible, so we can all get on with our day. So where is the map frame? Here it is. Okay, let's go from top number 1 to bottom NYC. I'm just going to add these as cards, and they should kind of pretty much line up with the bookmarks. So I shouldn't have to do too much going in and out of the map frame activation. Okay, so number 2 is Chicago. Number 3 is Los Angeles, which we have here as Southern California, which really surprised me that they were number 3. Would have thought they'd be number 1 for sure. And let's see, number 4, Boston. So I'm going top left, and down from there. Boston, Philadelphia, which is kind of an interesting one. Miami, which we named Southern Florida. Next up is Houston. So add that there. And then that's followed by Atlanta. Here. And then it gets a little slower as we keep adding these things. But again, lots of data. The fact that within a single human lifetime we've gone from this not even being a technology to having all the data created and being able to use it on consumer electronic devices, Windows apps, it's pretty amazing. And then finally, Cascadia, or as I put it, Seattle to Portland in the bookmark. And there we go. Next up is going to be creating the legend. And that's actually not too difficult, but there's a trick in that for these multi Variant Legends, we've got to go into the layer symbology and check Show Legend. And that will add that to the legend, and then we can create the actual legend based off of that. So we'll go ahead and create it there. And it looks a little small. That's because of the size of the template. Remember, this is that ANSI template that's pretty big. So let's just jump into the properties of the legend and turn off the layer name interstates. That looks good. What I did is I just saved this, or convert to graphics. I don't really have to do that, but then I can grab a screenshot of it as a PNG, and I do jump into Inkscape to finish this off. Give it all the names, make it look good. Again, not going to go into all of that. You could use Illustrator, you could use whatever you want, or you could do it right here in ArcGIS Pro. I mean, Ezra's made a ton of improvements in the cartography, but muscle memory, I still like to finish it off in a graphic design application for speed, ease of use. So that's really that. I made a Excel spreadsheet, or ChatGPT made an Excel spreadsheet of the table screenshot, and those got pasted right there, added titles to the map cards, and then up at the top right, we added our title. And that's really that. Didn't take too long, actually. I was concerned this video might take longer than anyone was willing to do. But we're done. We're done. So we can go ahead and check off finished for map number 2, lines. Tomorrow's polygons, which could be exciting or could be very simple and straightforward. Don't want to spend too much energy all up here in the front. We've got 30 of these to do. So please do stay tuned, and I will see you tomorrow for day number 3 and the map of polygons. Thanks for your time.